Hi guys, welcome back to my math YouTube channel. Today I want to talk about the antiderivatives, which are also called as the integrals. So before I start talking about the antiderivatives, I'm expecting that you guys already know the derivatives, how to calculate the derivatives and what is the formal definition of a derivative, and you have already practiced a lot of things about the derivatives. So antiderivatives, as the name suggests, is the reverse process of the derivatives. So I'm going to illustrate this concept with some examples, and then guys we are going to actually write the power rule for the antiderivative. I'm also going to write some other rules guys, but I'm not going to write all the different rules. I expect you to find those rules in your textbooks, or you may find a formula sheet online and you can just print one for your reference and use it when you are actually solving examples. So guys, without any delay, let us look at some examples and see what this whole antiderivative thing actually means. So keep in mind, there is two types. One is called the definite integrals and other one is called the indefinite integrals. So right now we are going to start talking about the indefinite integrals, and once we are confident with finding the indefinite integrals, then we are going to introduce what we like to call as the definite integrals. So there are two types. There's two types. One is the indefinite integrals, and the other one is called the definite integrals. The definite integrals, So right now we are starting with indefinite integrals. So guys, in order to actually try to understand this antiderivatives indefinite integrals, first of all I'm just going to say what does this actually mean in terms of the derivatives. It is the reverse of derivative. What does that mean? So guys, I'm going to illustrate that with some examples, and then from there we are going to be able to see a pattern and we will be able to deduce the power rule. Like we have a power rule for derivatives, similarly we have a power rule for antiderivatives or integrals, so we'll be able to deduce that as well. So I'm going to start with a simple example. Guys, let's say we have a simple function, an x function, a linear function, and we try to find the derivative of that linear function. We already know that the derivative of that is simply 1. So if the derivative of this, let's say it's y prime of this. So if the derivative of this x is 1, then that implies that the antiderivative, so we can say that the antiderivative of 1 is x. That is the whole idea of the antiderivative. It is the reverse process of a derivative. Okay. Similarly, let's say if I have x squared, then the derivative we already know is 2x. So from this, what we can conclude that the antiderivative of x is x squared over 2. So guys, let's look at this carefully. So I'm not trying to find the antiderivative of 2x. If I just have to find the antiderivative of x, and we're going somewhere with this whole process. That's why I'm not using 2 here. So if I only need to write the antiderivative of x, then I have to get rid of this 2. So that's why I'm dividing both sides by 2. So that means the antiderivative of x would be x squared over 2. Okay. Similarly, if I have x cubed here, then we know the antiderivative is 3x squared. And if I have to now write the antiderivative, so antiderivative would be antiderivative of x squared. I'm going to be only interested in the x squareds and x cubes and so on, is x cubed over 3. So, and then we know the power rule for the derivatives for x to the power n. We know that the derivative is nx to the power n minus 1. And now from here we want to also write the power rule for the indefinite integrals, which is we want to figure out what is the antiderivative. What is the antiderivative of x to the power n? So we may not be able to figure out that right away just by looking at this. Okay, so what we want to do is, guys, in these cases we were able to figure this out right away, but for this we have to look at a pattern here. And let us see if what we can do with these so that we may be able to see a pattern. Okay, so guys, this guy right here can be rewritten as x to the power 0 plus 1 over 0 plus 1. Okay. So I'm just rewriting these antiderivatives. And why are we doing it? We're only doing it so that we may be able to see a pattern. If there is any, we will have to see if there is a pattern. And if there's a pattern, then we can figure out, looking at the pattern, then we can figure out what is the derivative, antiderivative of x to the power n. Guys, you can see that happening with the derivative side as well. In the derivatives, we were able to see a pattern here, and then finally we were able to come up with this power rule for derivatives, right? The power rule for derivatives. Of course, there's other ways of getting the power rule. You can use the limit definition, you can use the first principle, and other ways of getting the power rule. And I'm sure you have seen all those different ways of getting the power rule, but this is like a, I like to call it as a quick and dirty way of getting the power rule for the derivative. Similarly, here we are trying to kind of discover or find out the power rule for integrals or antiderivatives, like using like a quick and dirty method. Okay, so similarly, guys, here is this first one for antiderivative of 1, which is x, and x can be rewritten like this, right? I'm not changing anything. Similarly, let us see if we can rewrite this in a same way. So yes, we can rewrite this as 1 plus 1 over 1 plus 1, because 1 plus 1 is 2, and same thing with the x square. Okay, guys, let us work on this one, x cube. We can write the x cube as x square plus 1, 2 plus 1 here, and 2 plus 1, right? So let us see if there is a pattern going on here. Guys, instead of writing a 1 here, I'm allowed to rewrite this as x to the power 0, because x to the power 0 is still 1. So when we are trying to find the antiderivative of x to the power 0, what are we doing here? We are just adding a 1 to the exponent, and we are dividing by the same thing, whatever is on the exponent, right? Now let us look at this. Of course, there's an invisible 1 here. So the antiderivative of this is x squared over 2, and this can be rewritten as 1 plus 1. So we are still adding 1 to the exponent, and same thing, we're adding 1 to the exponent here when in the denominator. Guys, let us look at this one. We are looking at antiderivative of x squared. So we know it's x cubed over 3 based on the fact that it is the reverse process of a derivative. But when I look at this side to see if there's a pattern going on here, again, we are adding 1 to the exponent. The exponent here was 2. We're adding 1 to that, and we're dividing by the same thing. Exponent was 1, we added 1 to it, same thing to the denominator. Exponent was 0, we added 1, and same thing to the denominator. So it seems like every time there is a pattern here, and every time what is happening is we're adding 1 to the exponent, and whatever is on the exponent goes in the denominator as well. So from this, I think we should be able to figure out what is the antiderivative of something which looks like x to the power n. And that is going to be x to the power n plus 1, because we see the pattern happening in these previous 3 cases, okay? And then what goes in the denominator is the same thing, n plus 1. Right? So that would be the antiderivative of x to the power n. We still have to fill in some more information to make it formal, but that is basically how one can get, like, with an using an easy and quick or dirty method to like finding the antiderivative of x to the power n. Guys, this is not the rigorous formal way of getting an antiderivative of x to the n, but looking at the pattern, at least we are able to see how we get this power rule for antiderivatives. Okay, so this I'm going to start, like, hold on to this in this video, because I want to take it to the in my next video. I want to take this up and I want to formally define the antiderivative, and there's few other things associated with it, and I also want to write some other rules for antiderivatives which are going to be very useful when we try to solve examples. But till then, I hope you guys understand what is the basic idea of an antiderivative and how one can figure out an antiderivative based on their knowledge of a derivative. Okay, so guys, just look at this carefully, and I will see you in the next video with a more in-depth analysis or formal analysis of this antiderivative. Okay, till then, take care. I will see you in the next video.